I'm Robin Carpenter, and I'm sure you've listened to KWMR, that lasting station that covers the whole Bay Area. But I do the Farm and Food Shed report for KWMR West Marin. I also write for Edible Communities on food and food supply issues and the environment. So we want to welcome you all here today for Earth Day. And we have a special guest, Kevin Lunny of Oyster Farm is here today. They're serving their wonderful oysters. And Kevin's going to come up and we're going to just chat for a few minutes about the carbon sequestration factor of oysters in mariculture and some of the restoration projects that are going on in San Francisco Bay. So join me in welcoming Kevin Lunny, third generation rancher. The Lunny Ranch was the first certified organic grass-fed ranch out in West Marin. And is that one on? Great. Okay, are we on?
Oh, yes, we are.
Oh, great. So, welcome, Kevin. And Kevin, I thought it would be nice if first you just briefly talk a little bit about the filtration and the carbon sequestration that mariculture provides and why it's being used around the country and the world to clean up habitats.
Sure, well thank you. It's wonderful to be here. People here that are helping us understand social justice, energy, and the part where I feel connected to what we can do for the environment and climate change is local food. One of those foods that are really exceptional are filter feeders. They're the oysters. And what they do is they play a very important role in our estuarine systems because they take what would otherwise be contaminants like nitrogen, phosphorus, and they process those nutrients and turn that into a very important protein and that we actually remove from the ocean system. And also, the shells, these are calcifiers, so the shells that the oysters form are roughly 50% carbon. And that carbon is sequestered into the shell into perpetuity. So it's a very safe sequestration of the carbon. So they play an enormous role, and at the same time as they're doing their filter feeding and providing this wonderful protein, they're improving water quality. The water becomes clearer. Sunlight penetrates through the water, aquatic vegetation does better. So it's a real win-win for both the environment and for those of us who like to enjoy our local seafood.
And one of the key things is because it reduces the turbidity in the water, you get eelgrass growth, which is where our forage fish and baby salmon before they go out to the ocean can feed, and it also has a great impact on what's going on in our fisheries up the line on that. Can you talk a little bit about, you guys have been providing the shells for a restoration project in San Francisco Bay to bring back some of the native Olympian oysters and some of the results that have been going on with that about increase in the young salmon and eelgrass.
Sure, that's been a really exciting project that Drake's Bay Oyster has been involved with because we operate the last oyster cannery in California, so we have a shell resource. The shells are left over from when you open up the oyster and put the oyster in a jar. So we've been collaborating with different conservation groups in San Francisco Bay to do a native oyster restoration project over the past few years, and it's been enormously successful. The scientists have said that we're having up to 40 recruits, 40 individual oysters colonizing on each shell. And the most exciting part is that we're seeing as those reefs grow, because we put our shells in forms that the native oyster larvae can attach to. And now as the oysters grow, they're providing those ecosystem services, the filter feeding. So we're seeing some of the first recruitment, natural recruitment of eelgrass around those new oyster beds, these oyster reefs. So we're seeing a recovery in San Francisco Bay.
Which has been a really fascinating thing because we weren't sure what was going to happen in that regard. And they actually tagged some, I think, baby salmon to see. And the salmon, one of the things they think of why the salmon have been so stressed is they don't get enough feed before they go out to ocean. So the survival rate out there is also an issue. And they're seeing these salmon come in and spend feeding time in there, which is sort of double duty of cleaning the water and also increasing supply for forage fish.
Absolutely. There are three-dimensional structures of these oyster reefs provide feed and foraging opportunities for predator fish, and the eelgrass, as you say, which is really a refuge for lots of juvenile fish. So it really gives those fish the strength to make it their next leg. Also,
the baby Dungeness crab. That's the eelgrass is very frequently referred to in sort of the fisheries world as the nursery. It's a wonderful, safe nursery habitat for the baby Dungeness and other small fish that are needing to bulk up before they go out to the big wide world. Can you talk a little bit about what's happening because of climate change with ocean acidification having an impact on our shellfish, and why climate change and carbon sequestration and these issues are so critical for our shellfish in the wild as well as aquaculture?
No, absolutely. That's one of the things as we talk about the effects that atmospheric CO2 and anthropogenic carbon from burning fossil fuels, we see the changes in our climate. That's something that we can all see, feel, and recognize the concerns of global warming and sea level rise. But the actual ocean chemistry is changing at the same time, and we're seeing a reduction in ocean pH, because as the oceans absorb atmospheric carbon, it creates a more acid or a more corrosive environment for calcifiers. So this is the problem we're seeing with our coral reefs, but it's also happening on the Pacific coast of our nation, because we have what's called upwelling. So the deep water moves up onto the continental shelf, and we're seeing a real corrosive, response and a loss not only of our native shellfish, but cultured shellfish in our hatcheries as well. So this is something that is becoming very, very apparent. We're working very hard to try to understand. A lot of wonderful minds working on this. But as we do culture shellfish and we can improve subaquatic vegetation, that vegetation is photosynthesizing. And as it photosynthesizing, it's using some of the carbon. It's actually adding oxygen back into our estuaries. So it actually acts as kind of a buffer where we grow our shellfish. So it's a symbiotic relationship that we really have to have.
And I know there are currently a lot of studies ongoing about some of the hatcheries along the west coast from Washington State down are working on that, because they have had issues with shell formation in the young, I don't know if you call them the hatchlings or the young seed.
Yeah, the larval stage.
Larval stage.
Their shells are especially sensitive, very thin. It's not really a calcium. It's a different calcifier called aragonite, and it's more soluble to these low pH waters. So we've had some wholesale failures in our hatcheries. So now they're learning about how to buffer the water. We thought it was, and it also, we were seeing other changes in the ocean, because as the pH reduces, different microalgae flourish, and so we're seeing some changes in the composition of the microalgae that can actually also be very disturbing.
Because a lot of that kind of algae and certain things like that also impact the viability of shellfish for consumption. Is that one of the issues?
Certainly. Some of these microalgae are actually produce toxins that can be pathogenic to humans. We've all heard of red tide and the organisms responsible for those kinds of safety hazards. Actually, sometimes it appears that they actually are doing better with this low pH water, which could be a real concern going forward.
Yeah, I know, because especially in an area also like Tomales Bay, which is one of our other major oyster growing areas, there's not as much buffer there, so it is of concern in that regard. Also, I thought it would be interesting just to touch a little bit on the organic cattle ranching and the learning about carbon sequestration out in West Marin. There's a marine carbon project talking about how properly grazed pasture lands can sequester as much carbon as a forested area. So that's been a study that's, I think, 3 years into the study of the Marin Carbon Project, talking about appropriate grazing and appropriately grazed lands and carbon sequestration. Can you talk just a little bit about that? Because that was fascinating for many of us who we just think, you know, meat bad, that actually properly grazed on pasture animals that are grazing animals can really help sequester carbon in those grasses.
Yeah, well, that is really exciting, and I think it's an appropriate discussion here because we're talking about action. That's action we can take right here in this county, and when you think about how much rangeland is being used in this nation for livestock grazing, improper livestock grazing, the way we've been doing grazing for actually generations now, have caused problems and have released carbon. Properly managed grazing, simply put, very intensive, very focused and planned, can do quite the opposite. And the data that are back are very impressive about how we can actually reverse that.
Well, Kevin, we want to thank you so much for joining us today, because one of the things in Western Marin we're so proud about is how our farmers and ranchers are working so hand in hand with our environmentalists and what we're discovering about how to raise food in an environmentally friendly and restorative manner. So thank you, Kevin, for joining us today.
Thank you.